The AI space race has begun. Why data centers are leaving Earth. Imagine waking up one morning to discover that the world's most powerful AI isn't running inside giant buildings on Earth. It's running hundreds of miles above your head. It sounds like science fiction, but it's not. The biggest technology companies in the world are quietly preparing for what could become the next trillion-dollar infrastructure revolution: AI data centers in space. For decades, the AI race was about building bigger models. Then it became about building bigger chips. Now it's becoming a race to build the most powerful computing infrastructure humanity has ever created. And Earth may no longer be enough. AI has hit a wall. Artificial intelligence is growing at a pace nobody predicted. Every new generation of AI, from reasoning models to autonomous agents and scientific discovery systems, demands exponentially more computing power. Training a frontier AI model now requires enormous clusters of GPUs operating continuously for weeks or months. That creates three major problems. First, electricity. AI data centers are consuming unprecedented amounts of power. Industry forecasts suggest global investment in AI infrastructure could reach trillions of dollars over the next decade, driven largely by the need for computing capacity. Second, cooling. Thousands of GPUs generate extraordinary amounts of heat, forcing operators to consume vast quantities of water and energy simply to keep the systems operational. Third, land. Modern AI campuses occupy hundreds of acres and require dedicated substations, fiber networks, and years of construction. Simply put, Earth is becoming the bottleneck, the radical solution. So engineers asked a seemingly impossible question. What if we stopped building AI infrastructure on Earth? Instead, what if we built it in orbit? A data center floating through space could receive uninterrupted solar energy for most of its orbit, eliminating many terrestrial energy constraints while freeing up land and reducing dependence on local power grids. The concept is now being explored by companies including SpaceX, Google, StarCloud, and other startups. Suddenly, the idea doesn't sound so crazy. Why space? Space offers something Earth never can: unlimited solar power. Above Earth's atmosphere, satellites receive intense sunlight without weather, clouds, or nighttime interruptions over much of their orbit. Instead of relying on overloaded electrical grids, orbital AI computers could generate their own power. That's one of the biggest reasons companies are becoming interested in orbital computing. Less pressure on Earth. Today's AI boom is creating tension worldwide. Communities increasingly oppose massive data centers because of their electricity consumption, water usage, and environmental impact. Moving some AI computation into orbit could reduce pressure on Earth's infrastructure while opening entirely new possibilities for global computing. Processing data in space. Future satellites won't just capture information. They'll analyze it immediately. Instead of transmitting enormous volumes of raw imagery back to Earth, orbital AI could process the information on board and send only useful insights. Researchers believe this could dramatically improve Earth observation, defense, communications, and scientific missions while reducing bandwidth requirements. The company's racing into orbit. This isn't just one billionaire's dream. It's becoming an industry. SpaceX has publicly discussed using reusable Starship launches to deploy enormous orbital computing infrastructure powered by solar energy. Jeff Bezos has argued that the primary challenge is economics rather than scientific feasibility, predicting that space-based industry, including computing, could eventually become practical as launch costs decline. Google is also exploring long-term concepts for orbital AI infrastructure, while startups such as StarCloud, Lone Star Data Holdings, Cowboy Space, and others are developing technologies for space-based computing. The race has officially begun. But there's one huge problem. Space is unforgiving. There's no technician to replace a failed GPU, no maintenance crew, no emergency repair. Even worse, many people assume space is cold. It is. But cooling computers in a vacuum is surprisingly difficult because heat cannot simply dissipate through air. Engineers must rely on sophisticated thermal radiation systems, making heat management one of the biggest technical challenges. Radiation exposure, launch costs, communication bandwidth, and orbital debris add further complexity.
Gao.
This is why many experts believe fully operational orbital AI infrastructure remains years away. Why this changes the AI race. The winners of AI won't simply build better models. They'll control the infrastructure powering those models. Just as cloud computing created today's technology giants, orbital computing could define the next generation. Whoever solves energy, launch costs, thermal management, and reliable space operations could control the world's largest AI supercomputers. That represents an enormous strategic advantage. Beyond Earth. Today's conversation is about low Earth orbit. Tomorrow's conversation could be the moon, or asteroid-based manufacturing. Some industry leaders have already suggested that future space infrastructure could eventually include semiconductor manufacturing and large-scale industrial facilities beyond Earth, though these ideas remain long-term visions rather than near-term reality. What sounds impossible today may become ordinary within a generation. History remembers the companies that recognized the next infrastructure revolution before everyone else. The railroad age, the electricity age, the internet age, cloud computing.
Now,
the AI space race. Moving data centers into orbit won't happen overnight. There are enormous engineering, financial, and operational challenges still to overcome. But one thing is becoming increasingly clear. The future of artificial intelligence may not be built only on Earth. It may be built above it. And if that happens, the next trillion-dollar AI empire won't just dominate the cloud. It could dominate space itself. Why SpaceX could become the NVIDIA of space infrastructure. Most people think SpaceX is competing with rocket companies. They're wrong. The company's biggest competition may soon be Amazon, Microsoft, Google, Oracle, and every AI cloud provider on Earth. Because the next AI battle isn't about building another chatbot. It's about owning the infrastructure that powers every future AI model. And SpaceX already controls pieces of that puzzle. Advantage number 1. SpaceX owns the entire supply chain. Today's AI companies depend on dozens of suppliers. Cloud providers buy GPUs from NVIDIA, electricity from utilities, networking from telecom providers, launches from space companies, satellites from aerospace manufacturers. SpaceX is becoming one of the few companies that can integrate much of this value chain itself. It designs rockets, manufactures satellites, operates one of the world's largest satellite constellations, builds laser communication systems, develops launch infrastructure, and now it's planning AI compute in orbit. Instead of paying other companies, SpaceX increasingly pays itself. That's the same strategy that helped Apple dominate consumer electronics. Vertical integration creates lower costs, faster deployment, and tighter control over innovation. Advantage number 2. Starship changes the economics. For decades, putting hardware into orbit was prohibitively expensive. Launching thousands of tons of computing hardware simply wasn't realistic. But SpaceX isn't designing these data centers around today's rockets. It's designing them around Starship. If Starship achieves its goal of rapid reusability and high launch cadence, the cost per kilogram to orbit could fall dramatically compared with previous launch systems. Many analysts argue that orbital data centers only become economically plausible if this type of launch capability is realized. Think about what that means. A future AI data center may not require years of construction permits, power grid upgrades, and local opposition. Instead, it could be manufactured, loaded into Starship, and deployed into orbit. That changes the economics of AI infrastructure. Advantage number 3. AI needs energy more than chips. Everyone talks about NVIDIA, but the real bottleneck is becoming electricity. Every new generation of AI models consumes more power. Utilities are struggling to keep up. Permitting new transmission lines can take years. Building new nuclear plants takes even longer. Space offers something Earth cannot. Continuous access to high-intensity solar energy without weather interruptions for much of an orbit. That means future orbital AI systems could generate their own power rather than competing with cities and factories for electricity. In the next decade, energy, not silicon, could become the defining constraint on AI growth. Advantage number 4. Starlink becomes the AI network. People think Starlink is just satellite internet. But imagine something much bigger. Millions of satellites connected by laser links. Some provide internet. Others perform AI inference. Others store data. Others coordinate autonomous spacecraft. Instead of isolated satellites, you get a giant distributed orbital computer. SpaceX has already demonstrated large-scale laser-linked satellite networking with Starlink, giving it a foundation that competitors would need years to replicate. This isn't just an internet network. It could become the world's first space-based cloud platform. Advantage number 5. AI at the edge of space. Most AI today follows a simple path. Collect data, send it back to Earth, process it, return the result. That creates delays and consumes enormous bandwidth. Now imagine Earth observation satellites, lunar missions, autonomous drones, or future Mars expeditions making decisions in orbit instead of waiting for instructions from ground stations. Space-based AI processing could dramatically reduce latency for space missions while allowing autonomous systems to respond immediately to changing conditions. Researchers see this as one of the strongest use cases for orbital computing. A new business model. Here's something many investors may be missing. SpaceX doesn't need to become another OpenAI. It doesn't even need the best AI model. It simply needs to become the company everyone else rents infrastructure from. Just as Amazon built AWS before most companies understood cloud computing, SpaceX could build orbital AI infrastructure before competitors realize they need it. If OpenAI, Anthropic, Google, Microsoft, or future AI startups eventually rent compute in orbit, SpaceX would earn revenue regardless of which AI model wins. That's a fundamentally different business. Infrastructure businesses often outlast application businesses because every competitor becomes a customer. The long-term vision, a space economy. Orbital data centers are only the beginning. Once large amounts of computing exist in space, new industries become possible. AI-assisted satellite manufacturing, autonomous space factories, space-based semiconductor production, in-orbit scientific laboratories, lunar communication hubs, deep space navigation powered by AI. Each new industry increases demand for orbital computing, creating a self-reinforcing ecosystem. That's why many analysts believe orbital AI isn't just another technology trend. It's the foundation of an entirely new industrial economy. The hidden risk for Microsoft, Google, and Amazon. Today's cloud giants dominate because they own terrestrial infrastructure. But if the economics of AI shift toward orbital computing, they face a difficult choice. Either invest billions building their own space infrastructure, or rent capacity from the company that already controls launch vehicles, satellite manufacturing, and orbital networking. That strategic possibility is one reason the space data center concept is attracting increasing attention from investors, startups, and established aerospace companies. The AI race may soon become something much bigger. Not just a competition between language models, but a competition over who owns the computing infrastructure of the solar system.